What's up, Mr. Grassbarber? Got your 12 pack right here, big brother. And as we know, man, this thing fried, and I'll be honest with you, man. These, along with some messengers out there, they really should have used a little bit bigger relays. You can see that right there cooked pretty good. But there's a couple other things in here I'm going to change, man. I've already started on it. I took this strip out. I know a lot of people will disagree with me, but I personally don't believe in these. And I ain't saying I don't believe in them, they don't work. I just think it's kind of ugly. I got my ways I can pretty much do that's just as good as these that I've done in the past, and they've worked just fine. Basically, I get in here and I strengthen up this solder, man. I just literally just thicken up all the grounds connections of this to the path out to the ground. You see what I'm saying? Just strengthen it up real good all the way to the path to the ground. As you see right here, that's where that path to the ground stops. You know, I could strengthen it on up that way, but as long as you, I've noticed if you get up to right there, and then just strengthen up all the paths to grounds on all of them. You know, so you've got more current capability of the ground side of that. Strengthen it up all the way here on down. The power wire, the way the power wire was, man, you've had this good stiff 4 gauge here, but it came down to this right here. I mean, that, you know, pretty much defeats the purpose. That's pretty much going from a 4 gauge down to something equivalent to maybe like a 14 gauge. So I know this amp had to be starving for current. So I'm just pretty much doing a power wire upgrade on here for you. I think the way that I'm going to do it is I'm going to come in with 10 gauge wire, but I'm going to splice that wire up in 1, 2, 3, 4, 5 or 4. So I'm going to splice it up on the grounds right across here like this. So them grounds going to have a direct connection to these transistors. You see what I'm saying? And then on your power, I'm either thinking about putting down a solid piece of copper, or I may just roll with this, but I'm going to come in, boom, just like that, boom, boom, with the 10 gauge wire. So just like that right there. So I believe that's how I'm going to do it. I'm going to go ahead and replace these straps here too, these jumpers with some good mil-spec Teflon, and get these trimmers out of here for you, man. Make sure this thing's tuned right now. The output tuning cap is right here. I may do something about these as well, as I noticed this one wasn't even soldered, as you can see. I don't think I got any metal 620s, but I am going to take those off and check them just to make sure they all match. And I may do something to where I double up with using 2 caps at least to strengthen that up just a bit. But it should turn out good, man. Got a blown 470 there. They go a little low on the older amps like this, and go ahead and replace these with blue for you too. Once you hook these things up on an unregulated supply, it don't take long for them 470s to go. I am going to give you a call to see if you want to downgrade these two 2879s down to 2290s. It's all up to you, really. If you want to try the 2879s, just see what kind of output we have. But this is what you call an older school design with the high wraps, the 620s, all that. And I just want to keep it factory, man. Keep it TNT. Keep it TNT-ish. All right, man. We're going to get in here and get all this done, man. Get this cleaned up, too. I've already started cleaning up all the fluff. I mean, look at it. It looks pretty nasty. I don't like to leave a box looking like that. So we're going to get these feedbacks looking a little bit better, too, for you. I'm probably going to take these chokes right here off and put some 3-wrap chokes on. And this right here, for example, is feeding the output transformers, the DC, over to it, which is equivalent, you know, for being a short run. But we're, of course, going to go away with that and put some bigger chokes on there for you on the output transformers. And I would do like a B plus type deal, but you don't got a lot of space right here. I even thought about moving these dang collector to ground loading caps on the sides here, but you know, that's just cosmetic. All right, man. Old gatekeeper, we good and gone. We'll be back. Alrighty, coming right along now. Got this thing all cleaned up, man. Got about an hour and a half plus just in cleaning. Alright, man, we got the new relay dropped in. Went ahead and put you some new SO239s in, gold-plated Teflon SO239s. I use them as heat sinks when I'm soldering the wire to them, so that center conductor don't come loose, or there ain't no possibility for it coming loose. Went ahead and took this back panel completely off and roughed up the bottom and everything so we can get a good ground connection to the heat sink at least. All right, we got your preamp installed with invert circuit, so now you'll be able to actually run this preamp on with the box turned off. Okay, all these right here are not Teflon wires. I'm going to remove all of them and replace it with some good 22 gauge Teflon, which is absolutely perfect, adequate for this. That's what this is right here anyways, 22 gauge. All right, man, we're going to replace these this coax here with some RG 142 mil spec, some good thick Teflon, pretty expensive coax. Alright, on to the next. We got the mini coax already soldered up, so the RF's ready to flow on down here to the high, low, medium switch. We're going to replace those resistors too with some 5-watt ones probably. And all we need to do at that point, man, is like I said, replace this coax here. And I might do one long run. I'm gonna have to wait and see. Might do one long run and then go up from there to here. Might put the tuning caps right here at the relay instead of all the way back here. And that, I ain't gonna roll with that. We're gonna put some bigger tuning caps in here, probably break it up too in 2 different places. Alright, on to the next step. Alright, big brother, I was going further with this thing, man, and something just kind of told me to go ahead and relocate the 120s to make a little bit more room right here. And just for the heck of it, I began checking them on my cap meter here, man, and quickly found out that that they don't match. So I'm glad I checked that. And now since that's done that, I'm going to have to take the caps off every other spot and check them, man, because I'm just a firm believer in making all the capacitors identical in capacitance. Alright, so let me go ahead and demonstrate that now. Here's a 120 right here. Try to hold this thing on my neck and do this the poor man's way. Alright, that's 117. Get that out of the way. 117 picofarads. Alright, we'll grab another one. 122 picofarad. Another one, 123, 124, 123 picofarad. I checked the other ones. You got 122, 121. That shows me right there that they were just grabbed out of a capacitor bag, a bag of capacitors, and they were not matched. And so what we're going to do, man, is we're going to go through this bunch here, which won't take long because these are, as you can see, 1%ers. You don't run across many of these, but it's good to have some 1%ers. It does not take long to match. So we're going to find us 8 of these. Here was the 2 caps on the driver, which are 330s. That's why I really do think that these are supposed to be 2290s here, but I could be wrong. But since these are 330s on here, they are attempting to back this driver circuit down a bit so it's not at full bore. And just to be real quick about it, 332. Ooh, I felt that phone falling. That's a 120. Where'd that other 330 go? Where is it at? There it is, right there. $338. See, they're not matched either, so that's pretty much going to make me have to check everything else, all these 620s. I just want to make sure this box is done right. I know this is going to take a little extra time, but it's just best to do it the right way. Woo, dog, yeah. Son. Go ahead and light this celebration cigarette, because I will admit this was a little bit of work. This is what I call pretty much a full rebuild. Mr. Grassbarber. Here is your finished TNT 12 pack. 1200. Advertised as 1200 watts PEP, which we're about 200 watts shy of that, and I will explain why. I have done about everything I knowledgeably know how to do this bad boy to get as much watts out of it for you, my friend. Whew. Let's go over here and take a look at what all came out of it. That's what I mean by it's pretty much the full-blown rebuild. Of course, one of the main reasons was this board being pretty much fried. So we had talked about, you know, just putting some new relays and a new preamp in it for you. Here's your power chokes that was powering the output transformers, kind of like old Texas Stars power chokes. Maybe some old 22 gauge, 20 gauge solid wire. That was the bolt for the ground right there. Let's see what time it is. Getting to bed, boy. One of your feedback resistors was very, very dark. I don't have any of these in there, so you in stock it looks like these, so they would not mismatch. I went ahead and replaced all of yours with some matching 1%er. Somebody had been playing with these tuners, man. One of them seems to be all seized up too, so I took them out and had to do some work in the tuning section and make me a little tuning section. All your caps were not matched. These are all the silver dip micas that was in the box. Whew. If you don't want none of these parts back, bud, I'm gonna take some off the price for some of the parts. Some of them, you know, I can't reuse. Like all the used caps, I can't reuse them. I don't use used caps, silver dip micas. Some of these resistors I might be able to reuse them some personal projects. Went ahead and replaced your SO239s with some good gold-plated Teflons. These are all your hookup wires for the switches, which is non-Teflon. Went ahead and replaced that with Teflon wires. There's the big strip that was across the pills there. I used it for some desolder and braid too. There's the input transformer on the driver section. I just went ahead and took that off, put you a 1/2 inch on there. I don't really like using these 1/4 inch transformers. I mean, they work fine, but you know. There's your output tuning cap, 91 picofarad tuning cap, which had devalued itself down to about 82 picofarad. Okay, just from getting hot and cooling down probably. And so I went ahead and replaced that. Well, I retuned the output. It turned out right there about 119, 118 actually, 118. And a couple other things. Here's your biasing resistors. One of them, actually it's that one, had showing bare metal. Plus these are 18 ohm resistors. I don't usually use those. So I went ahead and replaced it with 10 ohm. So anyway, there's your part sheet, brother. Not to bore everybody. Went ahead and replaced your power wire, which was a solid welding cable 6-gauge wire. There's your ground wire. It's pretty short. Went ahead and replaced them with 5 10-gauge wires stretched across the whole hot bus. Equal current to all 4 output transistors. Transformers, excuse me. And this is what I meant by you don't have to have that pill strip, man. The strap's going across the transistors. As you can see down each of this down here, I have strengthened up the solder and made it thicker on all of them, okay? As you can see that, just pretty much the path of the ground all over the board has been strengthened up. And not only that, now you got 5 10-gauge wires that hit every section. I replaced all your screws on the whole board with some, I think it's some 304 stainless. And I went ahead and put ground lugs on these screws. So these ground lugs are wrapped around each of the 10-gauge wires. So these wires are not only grounded to the board, they are grounded to this heat sink too. So that's, you can't get better than that with the ground. All of them are done that way except the ones on the ends here. So the whole every pathway to the emitters are grounded as good as they possibly can be. Alright, over here at the tuning section, the way this was set up, the driver section came out and was banged directly into the main splitter right here. And it was sharing a tuner, and that's not really usually how I tune things. I like to tune each section individually. So what I went ahead and did is put a copper bus down right here. And I put you a copper bus down right here too, because believe it or not, once I pulled this up, that copper just pulled off, man. It completely pulled off the board, so I had to put one there anyway. So I went ahead and put you a bus right there. So if you follow the RF come out of the driver now, this white wire goes to this bus. There's your tune for the output of the 2-pill section driver. It goes through these 2 4.7s on into the splitter, the main splitter, to a sub splitter, to a sub splitter, into the 8 pills. Okay, and then there's your tune right there. So everything has been individually fine-tuned. There was 1, 2, 3, 4 tuning trimmers in this thing when it was said and done. And it's having a little problem here on your transmit. The way they got it done is they've taken a little cap here and sending a little bit of the RF this way for your transmit LED. I just went ahead and done it the old school way, well, the new school way, shall I say, for your transmit LED, where it's running off the negative of the relay. Alright, and just to save a little bit on the wires from having to have ground wires go here to the board or whatever, this front panel is not aluminum, it's steel. Okay, and as a lot of you know, you can solder to steel, no problem. So we actually have the current limiting resistors, which is grounding the LEDs, soldered to this back plate. And this back plate is grounded very well to this heat sink, so they're getting perfect ground. Alright, man, as you see, I've matched every single one of your capacitors. None of them are matched. They just, I guess, they either took them out of bag or just over a period of time they've, you know, fell off the wayside. But these right here are equal in the 6. See, I kept everything the same. This is see what this is an old school way of doing things. It's what this is. These amplifiers are usually not going to put out the same watts as the modern day Fat Boy Dave made, Gatekeeper, BBI, you know, some of the other guys' amps, 1, 2, 3, a lot of the main builders these days. These type design amplifiers just do not put out, you know, the same amount of watts as you will see these days out of the modern day builders. This is an old amp, okay? High ramp style, shorter transformers, the choice of capacitors. This is actually 680 on the output of all these transformers. And just, you know, a couple of other things. I won't get all into it, but... And went ahead and equipped you with a preamp with an invert circuit, so you can now turn your preamp on with the box turned off, as you see right there. If you can hear it, it's disengaging when I key. I key, now I'm unkeying. Key, unkey. I already see now one thing I forgot to do is put plugs in these holes back here. I meant to do that before I started the video. Man, I'm about ready to just hit the sack, man. I'm tired on this cow picking in. But anyway, I'm going to plug them holes up for you, bud. I didn't know if you wanted a remote or not. If you do, just let me know. Your string release, boy. You can hear that. You can hear that preamp working, even though we ain't hooked up to an antenna. The only other thing I do want to mention is you were having a problem with the driver section. Okay, as soon as the amplifier was being turned on, these transistors were getting blistering hot. I'm talking about blistering. One side, before I knew what was going on, this whole side of the heatsink was blistering hot while this side was cold. And I noticed that by rubbing my hand over it, you know what I'm saying? And I'm like, whoa, now. And I went straight over to the driver section and figured out what was going on. So you were having an issue with that, bud, before you sent it up this way. And that might have something to do with what happened with the relays up front. And as you see, we've got your new relays here now, okay? These transistors, they're not matched. I mean, they're the same lot. It appears that one's taking a beating more than the other. They definitely are not turning on at the same voltage. You know, I hit you up, man, to see what you want to do about that. If you wanted to maybe replace them with some 2290s, but I hadn't been able to get a hold of you. But I know that you are a technician yourself. You work on a lot of tube type equipment, so I'll just go ahead and let you know now. I can almost bet you 9 times out of 10. I can almost bet you 100% here, 99%. If you take these 2879s out, replace them with some better 2879s, it's in a lot better health, or with some 2290s, your wattage will come up in this box. Because like I said, I tuned each section individually, and when I do that, I can see what each section is doing. The driver section, being just two 2879s, was only putting about 140 watts into this 8-pill. That's how I could tell, you know, and that's when I checked the transistors, and I could, you know, I could tell pretty much then. You could tell one has been working harder than the other. They're not turning on at the same exact voltage, and the HFE value is definitely a lot different of the two transistors. I don't have, if I had two extra ones, I'd just throw them in for you, bud. So that's also why the box isn't doing as much as I feel that it could do. This is my first TNT 12 pack I've ever worked on. Maybe a couple other people out there can kind of let me know what these boxes are supposed to be doing. But also, with this being two 2879s, this is considered more like a high drive amp in a sense, or you could say a medium drive. That's why I got this driver right here, because it takes a certain amount of power to get those 2879s even up and rolling. And as I said, they're only doing about 100 well, with the bench radio, probably about 120 watts or so, maybe 110. And when you hit it with hot radio, they're doing about 140. So the 8 pill's only getting 140 watts. Usually we'll drive a lot more than that into it. So you're about to see all I'm getting out of it using the hot radio and everything's about 600 bird and a little over 1,000 watts. And that's pretty much working like a 6 pill in a sense. So that's it, man. I was just wanting to point that out to let you know, so you can replace that if you wish. Or, man, you can run this box all day long like it is, man. This box is tuned very well. There's no reflect. It's running good and cool. This is 14 gauge chokes, replacing the normal 22 or 20 gauge chokes. I mean, this, and also this another thing, the coax. The way this was set up, it had two pieces of coax. One right there to this little pad right here, as you see right here that I've cleaned right here. And then from there, the other coax went on. I think on these versions, from right here to on, they have like two 1000 picofarad silver dip micas that they have in series with the RF, and I don't really know. I think they're just doing that to extend it. What I went ahead and did, man, to be a little bit more efficient, is just replaced it with one length of coax, as you see, that goes over to the final pad right here, then goes over to the relay. And this is some good RG, I can't even remember off the top of my head now. It's kind of about the same as some RG303. Some heavy gauge Teflon coax, pretty expensive, about $4 a foot. So that worked out real well, and I got something kind of, you know, that coax isn't the most flexible in the world because it is a solid center. All right, well, let's get on, man. I think I've done enough explaining about everything. Let me show you this bad boy in action. All right, we're on the 200 amp supply, iron core supply over there. Here's the voltmeter for that, okay? This is the voltmeter for what the driver's on. We ain't got the driver on right now. Alright, then showed you the receiver. The sideband delay is using a different type sideband. This was the sideband delay cap factory. Okay, and the reason why a cap this small can work, because it was working in a different manner. Okay, a different manner. I won't get into all that. So there's your sideband delay cap now, and it works great. All these other wires, the way they were here, they were just kind of falling over the circuit, you know, different parts of the circuit. You know, it's more clean and it's Teflon. So I just like it that way better, man. All right, let's get on with the show. We'll just leave it on high. All right, here's what we're getting, just hitting it with the bench radio, okay? 4 watts drive into it. RMS. Ooh, yeah. Ooh, yeah. Almost 400 watts. Peak. Ooh, yeah. 1,000 watts. Alright, here's your input tune. Ooh, yeah. Ooh, yeah. Beautiful tune. It's dropping to about 17 volts, which I'm going to say. The amp's not pulling real hard. Like right now, I can actually be running on the 100 amp supply right now. but not after I hook the driver up to it. Alright, now we're just going to hook the driver up just still with the bench radio, okay? Just kind of show the different drive. And we ain't going to show no more peak until I have to put in a different slug for that. Alright, we got the driver all the way up. This is going to be putting, let's see. Ooh, yeah. Ooh, yeah. About 30 bird. Okay. About 30 RMS. Dead key in about 400 watts. Ooh, yeah. Not swinging too much more than what it was. Ooh, yeah. And it's dropping to 16.3 now. Damn alligator clip fell. You think I should leave that in a video of Gatekeeper making some sparks for the first time? I don't think so. What I'll sit there thinking about something. I came close to making my mind up that I was going to edit that out of that little accident that just happened. We're all human. We all make them. And actually, I don't know if you would consider that being an accident I made. It's an accident that the alligator clip made. That dang alligator. It was just, you know, for some reason, I guess I bumped it a little bit and it kind of fell. I went to grab it and it touched a little bit and it sparked. Look, man, if you ain't created a spark in your life, and you ain't messed with electronics, that's all I got to say. Okay? But now I've got it more safe on the power switch here. Okay, so it ain't going to fall. That's my apologies. I'm not going to edit that out. I've never edited anything out in any of my videos ever before. I ain't going to do it now. If somebody wants to say something bad about that happening, just say it. Hey. Every other body that makes sparks, there's sparks made all week long from people working on electronics. Just some of us choose not to show it because it's unprofessional to show an accident like that. Well, let's just thank God nothing was harmed, okay? Alright, we're on the hot radio, Stickman modified, 8 watts RMS. We're driving it into the old driver here that's bumping into the 22879s on into the 8. Alright, we got the float voltage right there. Here's what we're looking at. Right there about 700, so it's 100 more than what I was thinking. 14.9 on the voltage drop. Alright. Let's go ahead. What do I got right here? 2500 watt slug. Alright, let's go ahead and put the 2500 watt slug in peak and just see what we got going on in peak. On the peak end of things. Top scale, the 10 is 1000. So right there about 1200 watts. Well, I'll take that back. I was able to get 1200 out of it. Hey, maybe that spark helped things out. What you think? I'm just joking. I'm gonna get this unplugged over here without anything bouncing together and sparking here. I'm just gonna kind of turn the amp around, just show it from a different angle. Go ahead and unplug that. Alright. So yeah, like I said, man, I'm sorry. I meant to put the plugs in here. I don't know why all those holes are there. I know that right there had the ground. Right here, this bolt right here is for the ground. It had the ground on.